Okay, hello, it's another awesome day. We're learning module 14.4, and today is all about graphing. I don't know if you remember, but I told you not to focus too much on the graphing portion in module 14.3 because module 14.4 is all about graphing, right? So here's your essential question. Go ahead and write this down. How do you graph an exponential function of that form? And so that is the generic general formula for an exponential function, which if you look carefully looks very similar to the geometric sequence, right? Okay, so today I want to go ahead and utilize the interactive site over here and also the copy of your printed version. So if you want to know how to go to both of them, you should know by now. But if you go into your Google Classroom, you'll see that the first link where it says high school math right here, this one is the interactive site that we are using that I usually use to record. And then if you click on the second link, which just says link and there's no picture showing all the time, that would be the printed copies that you have, but it's online, right? Okay, so there you go. I'm gonna go ahead and utilize both today because sometimes it's easier to look at this printed version, right? But sometimes it's easier to see the interactive version. Anyhow, it's the same essential question here, so copy that. Today we're just talking about graphing. And it's really cool because look, it says they give us four graphs here and then they want us to, four equations here and they want us to go ahead and match it with the correct graph. And so this looks like fun too, but if you go into interactive section, look, it looks even better. They give you the four graphs and then they have the four equations at the bottom and all you have to do is move the box like so to the correct one. And of course, you can check your answer. That's why I really like this interactive version, okay? So I really highly recommend that you study using this. But then if you want to see all your information organized, you can go ahead and use this paper version because that's how I do it. So then there you go. In order for you to figure out which graph goes with which equation, you're going to have to graph it. And a lot of you were having a difficult time yesterday because you have to actually pick numbers, pick x values, and then you have to calculate it, and then you have to plug it in. And today, I'm going to show you an easier way of doing it, okay? So I don't know if you've seen this tool, but you see this little thing, a circle with, I don't know, is this a screwdriver? And what's that? A wrench? Okay, so anyhow, if you click on that, guess what shows up? It says graphing calculator. And if you click on that, you can actually put in the equation and graph it yourself. So I'm going to do it really fast over here. I'm going to go ahead and graph every single one of these equations and see which graph matches with the equation. So the first one is y is equal to 2 times 2 raised to the x power. So there you go. I'm going to put 2 and then you know what? Just like the picture, I'm going to see if I could put another parentheses. You see me using the parentheses here. And then 2, close parentheses, and then raised to the power of, okay? And then I'm going to put x. And let me see if I can graph that. Okay, so it does not work that way. It says error in format in y sub 1. And I already know what the problem is. They don't want to see parentheses. They want us to specifically say times because that's what it means, right? When you go in here, the 2 and then parentheses 2 means 2 times 2, right? We put the parentheses because we don't want people to get confused and think it's 22. We want them to know it's 2 times 2. So what I'm going to do is I'm going to put 2 over here and then I'm going to put times and then 2 raised to the power of x. When I graph it now, it pops up. You see, the graph looks like that. So what I'm going to do is I'm going to go back and I'm going to take a look at the graph that looks like that, which would be A. So what I'm going to do is I'm going to click on this and I'm going to drag it up to the first graph. And I'm going to place it right here, okay? Now, let me take a look at the second one. Negative 2 times 2 raised to the x power. There you go. So I put negative 2 times 2 raised to the x power. Okay, so I graph it. Oh no, is my screen frozen again? So I really don't know why, but my screen gets frozen very often. Oh no. And then whenever I use that graphing calculator over here, this happens too. So I hope that doesn't happen to you. But what I'm gonna do is I'm gonna pause really fast and then I'm gonna go back. Okay? Okay, so the graphing calculator that is part that came with this crashed on me, which is fine because what I'm going to do is I'm going to tell you to go into the Chrome store. Now I'm going to tell you to download, go into the web store, and then I want you to go ahead and download Desmos. So if you type Desmos graphing calculator, you would see it's right here, and it will tell you to yours is different. I already installed it, that's why it says rate it, but yours will kind of look like this, plus free. So just click on it and then add it. Okay, so then you can go ahead and launch it, and so hopefully this won't crash on you all of a sudden. I don't know why the graphing calculator that comes with the textbook crashes. So now I'm going to move on to the second equation. Okay. So we already know that the first answer, the first first equation went with the first answer. And so we put that down, and I already know that's correct. Now I wanted to go ahead and plug in this one right here. Ah! So what I'm going to do is, I'm going to just go ahead and plug it in here. I'm going to put y equals, right? And then I'm going to put -2. And then I'm going to put raised to the power of, -2 times. And over here, I think you can use a calculator. Parentheses. Times 2 raised to the power of, and the raised to the power of is still the same, I believe. Where is it? Oh, it's this one right here. Raised to the power of, and then you have to press X yourself. And so press the X here, and you can see the graph here now is going that way, right? So then what we're gonna do is we're gonna go back and find the graph that looks like that. Oh, it's this one. It went like that, right? So there you go. Let's go ahead and select that and put it on next to the second graph. Okay, so the third and the fourth graph, I want you to go ahead and do it on your own, okay? And so I just clicked on check to see if my two answers on top were correct, and they were. The other two, since I didn't do it, it says that I have partially answered, right? So I'm not doing that on purpose, so you can go ahead and use the Desmos calculator. It's good for so many things to go ahead and graph it yourself, okay? So then after this, they ask you questions over here, okay? Let me go to the paper version. So we're going to assume that we're done with this. We already know that the answer that goes with number 1 is A. We already know that the answer that goes with number 4 is D, okay? And so you have to work on B or C in the paper version, okay? In the interactive version, it was a little bit different. So let me look at all the questions here, because sometimes looking at the questions is just much easier over here. I'm gonna make this a little bit bigger because I know some of you just cannot see. Okay. So let's take a look. The base B is greater than 0. Just in case you guys don't understand what A and B is, let's take a look over here, okay? You have an equation, and you see the first number was A and the second number was B. So what is A here? 3 is A. And what is B? B is 2. Get it? And so over here, what was A? 0.5. And what was B? 2. And so I just wanted to clarify what they mean when they talk about A and B. Okay? So in all the functions, it says that B was greater than 0, because I think B was all 2, 3, stuff like that, right? So let's take a look at all the B's. The B over here was a 2, 2.5, and 2. So it's right. They were all greater than 0, right? And so you can use the graph to make a conjecture. State the domain and range when A is greater than 0. Okay, so let's take a look. What are the domain? Domain is just a fancy way of saying X. Range is just a fancy way of saying Y. Okay, so when A is greater than 0, what is the domain and the range? So let's take a look. when A is greater than 0. So A would be all the numbers here at the front. So not number 4, but number 1, 2, and 3. So what do we see? That's the same. So you know what? Just to make this easy, I'm going to go ahead and give you all the answers. Number 1, this one is A. This goes with that, okay? And then number 4, because we already did it, it's D. That goes with this one, okay? And number 3, just so you know, we already did A and D, is going to be B, okay? And then of course 2 would be C, okay? So I'm giving you all the answers so you can see the pattern. So we're going to not look at question number 4 because this one is a negative. We're only looking at number 1, 2, 3, which is A, C, and B. So A, C, and B. And we're not going to look at D, okay? So what do you notice, right? When A is greater than 0, what do you notice? Well, you notice that they are all on top of which line? They're all on top of this x-axis right here. All 3 graphs are on top of that line. Because what do you notice about D? Well, the graph is underneath, right? Okay. So that is one thing that you can see, right? All right. So let's see. The domain would be the x values, and so for all 3 of them, all the x values are everything on the x line, right? And what about the range? The range would be the y value. So you look, and then you notice that everything is on top, which means all the y values are positive, okay? So you can write that down. The domain is going to be all real numbers. And then the range is going to be just positive numbers. Or you can say x is equal to or greater than, y is, because range means y is equal to or greater than 0, right? So same thing now. Another thing, in all the functions, still the base is greater than 0, but we want to use the graph to make a conjecture. State the domain and range of y is equal to a times b raised to the x power when a is less than 0. Well, when a is less than 0, we only had one example. And that was number 4. And number 4, I said that the answer was D. So what is the only difference? Like I said, for D, the graph was over here, down at the bottom. So your domain could be all numbers, but your range, which is your x values, the graph is only here where the negative numbers are, right? So let's go ahead and write that down. Okay, so there you go. We're going to go ahead and write that down. We're going to say that the domain is still all real numbers. But then our range is now, if a is negative, is going to be negative numbers. Or using math, you can say y is less than 0. Okay? All right. So that is something interesting, right? So then what is the y-intercept of 0.5 times 2 raised to the x power? So then that would be this one right here, okay? So you can't really quite see it here, but let me go ahead and explain it to you. If you go back to Desmos and you were to graph it, okay? Let's go to Desmos. 0.5 times 0.5 times 2 raised to the x power. There you go. The y-intercept is where the graph is touching the y line. And so where is it passing? Yeah, 0, 0.5. And what is that 0.5? Isn't that the same as the a right here? Yeah, and that's exactly what they wanted you to know. Okay, so then your y-intercept right here, you're going to write it 0, 0.5 because that is where the graph is touching the y line. Okay? So it says note the similarities between the y-intercept and a. What is the relationship? The relationship is that they are the same. The a in the equation, right? This is the a, the 0.5. That is your y-intercept, okay? All right. And so that was a really interesting thing for you to understand. An exponential function, let me just summarize. Exponential function, okay, in general, looks like this. Okay, here's your x-axis, here's a y-axis, right? And that is generally how the graph looks like. And the equation looks like usually y equals a times b raised to the x power. Okay, and here's the really interesting thing. Okay, the y-intercept, okay, the y-intercept, which is basically the point where the graph is touching the y-line, this is a. Okay, so the y-intercept is the same as a. So if I gave you an equation like y is equal to 2 times 3 raised to the x power, if you graph it, you're just going to go like this, and then you're just going to say, oh, by the way, this is a 2. Okay, isn't that easy? So that's all we learned so far. So then now what they do, starting from explain 1, and then you have your turn question right here, right? And then they do explain 2, and then here's your turn question right here, and then explain 3, and then they have their your turn question right here, and then they explain 4, so another concept that they're explaining to you, and then there's your turn question, and that's it for your homework, right? And so I'm just gonna try and summarize everything for you really quick, okay, instead of me trying to go over every single step with you, okay? So let's take a look at explain 1. And let's just take a look at what it's talking about. We're graphing increasing positive exponential functions, okay? We're only looking at 2 things. Here's the most important thing. First of all, you have to understand that the symbol infinity represents infinity, okay? It's like a lying down number 8, okay? And that just means infinity. That means going on forever, getting as big as possible or getting as small as possible, right? So if you want to say that it goes on forever in the negative way, you put minus infinity. If you want to say it goes in the positive direction forever, you just put infinity. Okay, like I love you, infinity and more is what I tell my daughter and son all the time, and what that means is I love you forever, forevermore, right? Okay. And if I say I don't love you, like negative, I love you negative infinity, that means I hate you forevermore. But anyhow, okay. We can always describe the end behavior, so we're going to talk about this. This statement over here, it means as x becomes bigger, okay, as x becomes bigger, x goes into infinity, then something happens, right? And over here it says x is going towards negative infinity. What that means is if we have a line, and this is your x-axis, right? X going through infinity is saying, okay, what happens to the graph as we go that way? If I have a graph that looks like this, then as we go this way, what happens to the y values? Well, it's slowly going down. It starts from here, and as the x values go up higher, we're going down, right? So we can talk about that. And then if we talk about as x is going through negative infinity, well, now we're going to look at what's going on as we go towards this way, the negative way. Well, what happens? We're basically starting from here, and what are we doing? We're basically going up, right? So we're just going to talk about that. And it says graph each function, and what did they do? In the beginning, they gave us a function like this. And so the difference is, what is your a here? If you don't see anything at the front, that means your a is a 1. So in this case, this equation over here is kind of like 1 times 2 raised to the x power. So your a is positive and your b is positive. So what this lesson, explain 1, is trying to show you is that if you were to graph it, it's going to look like this. And then this point will be 1 because we just talked about how the y-intercept is going to be the same as a. Right? And in addition to that, it's trying to tell you that as x goes to infinity, the line down number 8, that means as the x goes this way, okay, what's happening to the y? We're going dun 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 dun. Oh, we're going up. What happens? The y values go up also to infinity. The y keeps going bigger, right? Now, what else? If x is going towards negative infinity, that means, let me use a different color now. As we are trying to go this way, what's happening? We're starting from here and we're going down, 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 down. What's happening to this graph? We're going down as x is going towards negative infinity or going towards the left. Okay? And so we're going to write that down. As x goes to negative infinity, y goes where? Not to negative infinity, because as you can see, the graph slowly keeps going really, really close, but it doesn't touch the zero, I mean the x-axis. It never touches zero and it just keeps going. So what happens is y keeps going closer and closer to what? The number 0. And that's all you have to know. That's all you have to know. When you have a positive number here and you have a positive number here, right? That is greater than 1. This number over here, b, has to be greater than 1. Then that's how it looks like. And that's it for explain 1. So then we move on to explain 2. Okay, so then obviously, how do you think your graph is going to look like on this one? We already know it's going to look like this, and it's going to pass through 2. So this is 0. We're going in increments of 3. So from 0 to 3, half is 0.5. So 2 should be like right here, somewhere around there. So your graph is going to look something like this. Okay, so of course you have to go ahead and plot everything else, and so your graph should be more accurate than mine. Okay, like for example, you got to plug in the 2 into the x. So 2 raised to the second power is 4. 4 times 2 is 8. So it's supposed to be actually like something like this. Okay, so totally did it wrong over here. But anyway, you get my point, right? You should be able to easily graph it based on the fact that you know that this is a positive number and also your y-intercept, and this is greater than 1. So you already know it's going to go like that, right? All right, so now let's go to explain 2. Explain 2 is just showing you how to graph something that looks like this. Notice your A, this is your A, and that's your B, okay? A and B. Notice your A is now negative, okay? And your B is still a positive number that is greater than 1, okay? So when we have a situation like that, if we were to graph, okay, you're going to have to go through every single step over here. But what's going to end up happening is if you plot this, you can always go into Desmos calculator and graph the equation yourself. Let me just show it to you so you don't get confused. So negative 2 times 3 raised to the x power. Negative 2 times 3 raised to the x power. So when I did that, what happened? My graph went down, and guess what? My y-intercept right here, the point where the graph touches the y-axis is right where? At negative 2 is at 0, negative 2, which is still the same value right here. The first number A, right? So just keep that in mind. So what is explain 2 trying to tell you? Well, if you graph an equation where A is a negative number and B is still greater than 1, not equal to, but just greater than 1, greater than 1, then you're going to have a graph that looks like this. And this point is going to be negative 2 because the y-intercept is always A. Okay? And so then let's talk about this. Same thing we did earlier. As x gets bigger and bigger, so as x goes to infinity, what is happening to the y? Well, we start from here and we're going down. And so y is going to what? Negative infinity, right? So then now, what if we're going this way? What if x is going towards negative infinity, going towards the left forever? Then what is happening? So we could start from here and then, oh, we're going up. But we're not going up like forever. We're going up and suddenly, slowly but surely, where are we tapering down to? We're getting closer to 0. But we're not really, because see, This is 0 right here. We're getting close to 0, but not quite touching it. So then what is happening to y? Well, y is getting very, very close to 0. And that is all this section is trying to explain to you. They want you to look at the graph, look at the pattern, and figure it out. And this is when a is a negative number. Okay, when a is negative, meaning less than 0, and when b is greater than 1. Okay, so that's what they're talking about. So then if you go down to the your turn question, of course, you're going to have the same kind of problem, right? Don't you think? Yeah. So then this is a negative number, so we know it's going to pass through -3. So this is in between 0 and -10, so this should be -5. So it should go through this one, get really close to 0, but we're gonna head down. Maybe I should have picked another number like 2, plug it in there. If I plug in a 2 here, 3 times -3 times 3 raised to the second power. We gotta do exponents first, right? So 3 times 3 is 9, so -3 times 9 is -27. So then when it's 2, I'm supposed to be at -27. So this is -20, -25, somewhere around here. I always draw my graphs too fat, don't I? So then let's just make sure I graph it so it looks a little bit thinner. But yeah, that's the whole point. This is how your graph is supposed to look like, okay? Now I'm gonna go ahead and move on to the next one. This is explain 3, doing the same thing. So this time, what are we doing? We have nothing at the front. That means we have what? F of x is equal to 1 times 0.5 raised to the x power, right? So what is our a? A is 1, and what is our b? B is 0.5. So the pattern you have to notice here is that now we're talking about situations when a is still positive, right? But then b, what happened to b? B is less than 1, but is still greater than 0. Okay, so we're talking about that situation right there. When we have a situation like that, oh, they already showed you a graph here. I didn't know that. Why did I go into decimals every single time? I should have looked at the textbook a little bit carefully. But what it's trying to tell you is that when you graph something like this, it's always going to look like this. You know why? Because when b is less than 1, but it cannot be a negative number, okay? So when it's like a fraction that is less than 1 or a decimal that's less than 1, so anything in between 0 and 1, your graph is going to look it's kind of like this, but then it's flipped the other way. It's kind of like looking at a mirror, right? So it's gonna go start from a lot and then it's gonna go down to almost nothing. And so that is what they're trying to explain to you right here. So now let's look at the pattern, okay? As your x increases, as x goes to infinity, what's going on? The y value is what? Going down, but how low is it going? Is it going down forever? No, it's just getting really close to 0. Okay, and now look at the other side. As the x values are going to negative infinity, going towards the left forever, what's happening to the graph? I'm going to start from here. It's going up to infinity. The y is going up to positive infinity. And so that's all they want you to do. And again, don't forget the y-intercept is always a. So let's go back to your turn question, right? Well, how do you think, even without using a graphing calculator, how do you think your graph is going to look? We just talked about this. This is a positive number and the y-intercept has to be 3, right? And then it's going to look like this. It's gonna kind of look like this. That's a weird shape. But anyhow, let me just plug in a number, like a 2. You can pick whatever number, but I just want to plug in 2 because raising x to any kind of a bigger number is going to give me a headache. Okay, so there you go. 3 times 0.5 raised to the second power. We gotta do exponents first, right? So f of x is equal to 3 times 0.5 raised to the second power means 0.5 times 0.5. So that gives me 3 times 0.5 times 0.5 is what? 0.25. Then when we multiply this, then we're going to get 326, 35, 75. That's going to be 0.75. So when f of, oh, why did I put x over there? I'm supposed to put 2 over here because what am I doing? I'm plugging in 2, right? So I should have put f of 2 equals f of 2 equals, f of 2 equals, f of 2 equals, right? So anyway, when I plug in 2, I got 0.75. That's a little bit less than 1, so it should be there. Again, I didn't really graph it right? So this is a 3. And so this graph is going to pass through these points, get really close to 0, but not quite, kind of like that. Okay, so that's how it's supposed to look like. How did you know that? Because we already know that when a is greater than 0, and that's 3, and that's also the y-intercept, and then when this number, when b is greater than 0 but still less than 1, we know that the graph looks like that. And that's what we did. And just to make it really accurate, what we did was we just selected a number from the x value, like a 2 or a 4, and then we just plugged it in so we know how to graph it just about right. Okay? Are we almost done? I think we only have one graph left. Yeah. Here's explain 4. Okay? With explain 4, what kind of situation do we have? Again, we don't have a number at the front. Well, actually, we do. We have a -1. Because look, guys, when we raise something using an exponent, you gotta remember you're only multiplying the 0.5 that many times, okay? The -1 is waiting outside. The reason why is because it's not in parentheses. If it was -0.5 raised to the x power, then we have to keep multiplying -0.5, right? But look at this. There is no parentheses, right? So what that means is the -1 is waiting, and then we're only multiplying 0.5 many times, okay? So that is what that means. So what is your a here? This time your a is a negative number, and what is your b here? Well, b is still greater than 0 but less than 1. This is really important. And so when you have a situation like this, you have to remember, let me scroll down and see if they drew it for you. Yeah, they did. So you have to remember that the graph is going to look like that. Okay, so let me just put it like this so you can see the graph and you don't have to see my ugly graph. So a is -1, meaning it's less than 0. A is less than 0 and B is greater than 0 but still less than 1. Then you'll have a graph that kind of sort of looks like this, okay? So the shape is basically just that, all right? And so what are some of the other things that you have to know? Well, let's see. Same thing, okay? As the x goes to positive infinity, what's going to happening to the y value? We're going up. We're going up, but are we going up to infinity? No, it's just getting really closer and closer to 0, right? So let's just go ahead and write that down. As x goes to infinity, well, what's happening to y? Well, y is getting closer and closer to 0. Okay, cool. So let's use another color now. What if x goes into negative infinity? As x goes to negative infinity, what is happening to the y? Well, let's see. We start from here. It looks like we're going down and down and down forever. Y is going down and down and down. That means negative infinity forever. So that's all. Again, same thing. Our very first number over here is what? -1, not 0.5. 0.5 is b, okay? I told you this is the same as f of x is equal to -1 times 0.5 raised to the x power, right? So what is our y-intercept going to be? Yes, -1. So this is a really important thing that we have to understand, and we keep doing that over and over again. Instead of showing you how to do your homework, I should let you do that on your own. Let's just go ahead and take a look at this one. This is a is negative, and then look, what is b? B is greater than 0 but less than 1. So we already know that it's going to look like what we were just looking at, right? What was it? Miss Choi forgets really fast. Yeah. This one right here, right? Yes. So it's going to look like this. And then it's supposed to get really close to 0, right? But then I want to make sure that I'm doing this accurately. So what is my y-intercept? -3. So my y line is going to pass through -3 and it's going to look like that, okay? And then I said we're gonna go ahead and just plug in one number just to make sure we know what we're doing. Okay, so let's just go ahead and plug in 1, okay? So there you go. F of 1 equals, instead of x, I'm just plugging in 1. Negative 3 times 0.4 raised to the 1 power. So PEMDAS, we gotta do exponents first. 0.4 raised to the first power, you multiply 0.4 one time. So that is 0.4. So negative 3 times 0.4. What is negative 3 times 0.4? That will be negative times a positive is a negative. 3 times 4 is 12, and then 1 decimal. So that's negative 1.2. Negative, this is 3, so this is about negative 1.5. Negative 1.2 is just going to be a little bit closer to 1. So let's just put it right here. And then now we're ready, and then we're going to put it really, really close to 0. And then we're just going to put this really down low, okay? So if you wanted to, you can go ahead and plug in the 1 over here, negative 1 over here as well to figure this out, but I just didn't do it. So anyway, that's how your graph is supposed to look like. And so now let's go ahead and summarize. Okay, so then now we're almost done with our lesson. Let's go ahead and summarize what we learned, okay? So basically we are talking about 4 different situations, okay? And so what's going on is first situation is whenever we have a graph that looks like this, y equals a times b raised to the x power, we're talking about many different situations for a and b. When a is positive and b is also positive or greater than 1, your graph is going to look like this, okay? And then another thing that you have to notice is that as x goes into infinity, y goes into infinity, right? And then as x goes to negative infinity, y goes to what? As x goes this way, y gets closer to 0. Okay, and the second situation was when we had a is less than 0 is a negative number and b is still greater than 1. In that case, what happens is now it looks like this has been flipped like this way. Okay, so that's how the graph looks like. Okay, and so what we have to know is that as x goes to infinity, as x goes to the right, y goes down to negative infinity, right? And as x goes to negative infinity, y goes to, as x goes this way, y gets closer to what? 0. Okay, and so the same thing. The third situation is when a is greater than 0 and b is in between 0 and 1. So it's a decimal that's less than 1. Well, in that case, your graph is going to look like this. It's called decay, right? And so the pattern that we're looking at over here is that as x goes into infinity, y goes towards 0, right? That's what's happening. And then x goes into negative infinity, y goes to positive infinity, okay? Because as x goes this way, what happens? Y goes really, really big. Same thing, the fourth thing is if a is a negative number and b is still in between 0 and 1, you have a graph that looks the other way. It's kind of like this one flipped down this way across this line, okay? So it's going to look like that. And so what you got to notice about this one is that as x goes to infinity, as x goes this way, y gets closer to what? 0. And as x goes to negative infinity, as x goes towards that way, y goes to what? Negative infinity. And so you see in the past what happened is a textbook would just give you a chart like this, and then they would expect you to understand it, and then they'll give you examples. But what we did was we did it in the opposite way. They gave us equations with numbers, right? And always remember, by the way, all the x-intercepts are what? It's always a. This is all a. Okay, so just remember that. And so we're just learning it the better way, where you get to see the examples and so you can experience yourself. So After that, when you look at this chart, it's like, oh wow, I understand it. Okay, so that's it for today's lesson. When you come to class, of course, we're going to start working on this section where it says evaluate. So in class, this is when you start working and start graphing this, okay? So anyway, I can actually go ahead and do 1 and 2 with you really fast. Based on the information we have, A is positive, B is positive, so we know it's going to look like that, and we already know that this is going to get closer to 0, and this is infinity, and we know that this number is 2. Isn't that easy? And then let's take a look at the second question. This is negative and this is positive. So we know that it's kind of it looks like this, but it's kind of like flipped. It's supposed to be like that. And this number is going to be what? -6, right? So we already know how to graph everything, right? It's not going to be exactly the same, but we kind of know how the shape is going to look like and what number this is. And that is really all I care about. If you pick another number here, like say 2, and then find an accurate point for this one, that would be even better, but it's up to you. So in the classroom, this is what you're going to do. You pick any of the 3 questions, like one from there, maybe one from over here, okay? And then here's the part where we talk about video tutorials, because we're almost at the end of this module. And so you know how I talked about you need to do 4 video tutorials on your iPad, record it and put it online for everybody to see. These are the kinds of questions that I want you to be able to work on and be able to explain to other people. So for every section, if you go to the very bottom, you will see the lesson performance task. I want you to try and work on it and see if you can solve it. And if you cannot, ask me for help. You can go ahead and get into groups. Pick something that you feel confident with, and then I want you to go ahead and come up with an idea to create a lesson. And that's something that you have to do. You have to do 4 of them for the whole semester. So just keep that in mind, okay? So that's it for today. I'll see you in class. Goodbye.